hey, just want to make a video just saying that I'm done with what I wanted to make. And well, it's pretty messy. But I guess that's expected when it's your first time making something. Well, making this. Anyways, it's 100% just made with Reaktor and obviously Control Editor. Basically what it is it's kind of like using the controls that, you would see in Maschine or any other DAW. Basically kind of like a work environment that would show up. That would be in that, but I've kind of like programmed it myself for the controller. I guess that's a rough way of explaining it. But yep, so if I guess I don't really have any other DAW open, just Reaktor. Just one instance of Reaktor. There's background Alienware key thing, which I could actually probably get rid of. Well, that's, I guess, different. And I have nothing else, no other DAW, just Reaktor. So this is just 100% what I was doing, just Reaktor. It starts with this channel message actually right here that I'm wiggling around. And what it does is I set up all the CC values in here, and so when I play something, this shows up, what channel of the button I'm pressing. All these pads are set up channel 1. Everything else is channel 2. That's just how I kind of did it. Just to help me like identify what's what. Numbers, it'll show me the number of each pad. So this is kind of numbered 0 through 1, 0 to 8, then 16 to 32, and then yeah, so on. And this would be 64 as it shows up when I go in the debugger, things open. And it always shows 1, but that's like, it's just a trigger. So it's just an event being triggered showing through, hey, you've clicked that. And then this kind of unpacks this information, and it's pretty sloppy. I could have went about it like a much better way of doing this, but let me turn this off so it doesn't keep initializing every time I open a core cell. But yeah, it just kind of like unpacks, and I get the controls like when I click this, what do I want to happen, and when I click this button, what do I want to happen. I turn the this off so the controller's not going to work. I did that intentionally so I don't keep hearing sound every time I open something up. But when I want an iteration to happen, like what controls are going to trigger that iteration, when they trigger the iteration, then I have a counter so that when I hold down duplicate, first time I hit down duplicate, it'll reset it, and then the second time when I hit one of the pads, it'll actually count 0 to 0, and then the second time it'll count to 1, identifying basically identifying where to route this. And those controls will set out the pad number and the group number, actually. I'm sorry. So actually you could see when I hold down duplicate, it'll clear it with the reset. It clears it. It's just a trigger, so you can't really see it being triggered. And then when I hold down the first pad, it'll set that value. Actually, let's make something first. I'll set that value. Huh. Apparently it's not showing up, but it did copy and paste because I see the same thing in both. But anyways, it just shows out the specific value that's right here. So for the first one, it'd show up, it'd be 0. Oh, duh, because I'm clicking 0. That's the pattern. Okay, so 0 for the first one, and then when I click the second one, it's the pattern 1024. Each pattern is 64 pads, so it's 64 times whatever pattern it makes sense to me because I'm the one who created it. And then I have this for multiplexing signals. Oh, there it goes, initializing every time I go through. But it multiplexes the faders, which I have in here. Then I went and routed them. Could have went probably about a better way than the way I just went about this, but like I could have, instead of multiplexing it, and then I don't know. And then I have this so I can control the length of each individual voice, because here, let me turn this back on. Each one of these steps is a voice. So this is voice 1, 2, 3, 4, 5, 6, 7, 8. So I could have went about a better way of doing this, but this is kind of just so I can control each length of the voice. I am writing each of them, and I can like send them out and read them, and I could read them if they were all the same length. But if you want to have the song position, which is actually in my globals, change individually, I could have probably went about a different way than doing it this way. Maybe I'd have to think about it a little bit. But yeah, so what that does, this gets the information of the controller. Well, this gets the information of the controller. This sets the values that I want, and then I have the iterators that determine what iteration I want. If I want every pad to be iterated, and I have an initializer for when it just starts. So where's my initialization? Right here. So as soon as it starts, no wait, where is my initialization? How did I set that up? I forget. Oh, right here. So this is an initializer sender. It just, what it does is it's just a hold with 1 on it. Actually, I can show you it in the globals. So it's just hold with 1. So basically, as soon as the program starts, it's going to send that 1, and it's going to hold it for 0 milliseconds, which is, it probably holds it. There's probably some set time, but it's set for 0 milliseconds. I don't know if it's exactly that. But then what that does, for that short amount of time, it allows the iteration to go through once as soon as I launch the program. So what that does is when I turn it on, is that it initializes this right here. So if I close the program, I don't want to do that. I don't want to reopen it up. But when I close it and reopen it, it'll initialize these values right here. And it also initializes the fader values to 1. So that's very helpful. So yeah, it basically, back to the iteration, it chooses whether I want to iterate all 63 pads, or if I want to iterate just 7 of them, which is what I used for this, setting the pattern length, as you can see. I could have probably went around and use this iteration for everything, but it would have been kind of difficult, and I tried to clip it with a clip min, but it didn't work for some reason, so I just made a whole new iterator with 7 values instead. And then the iteration gets sent through, and then it goes through a router, and this router determines where to send the iteration and on what thing to set the iteration to. So if it's the song step page, it'll set iteration there. If it's a pad mode page, it'll send the iteration to that group. So this pad mode is actually this block right here. This step mode is actually write steps. And then pattern select is this. This is pattern select. I'm sorry, this is pad mode right here. This is pad mode because the button's pad mode. Makes sense. And then I have the copy and paste function that have the values get sent to them from the other block that I needed to get those values from that I showed. And I have, this is a huge array, and it needs 40,096 bins. I don't know what you'd call that. Array areas? Bins, maybe? Yeah, I guess that would be a word for it. So those bins are each one of these patterns that you can set. So you can set a pattern in each group, and then you can have 8 groups and then 8 patterns for each one of these 64 pads. So it's 64 times 8, and then that times 8, which is that. So I can set a pattern here. Go all the way to the last group in the white group and set a pattern there, and yeah, I can set a lot of patterns, which it would be a total of 4,096 pads total to do that. And then the iteration gets sent out, and then it gets sent to the GUI. the best method, I tried to use a voice combiner, but the best method I've found to getting something that's poly to mono is just set to the first voice, especially when you have only things on the first voice for a lot of these values. I'm really using it poly just so that I can get all these separate voices for each instrument that I have right there. And then I have the GUI, which is it's a mess. But yeah, I don't know. This is the GUI, yep. And it's pretty responsive. So you can see right here on my screen, when I click something, it shows up, which is helpful and awesome. And then I can click something. You don't have to click on here. I can click on my screen and it'll show up in there, and I can hit the clear button on here instead of hitting the clear button on my controller. So I try to like replicate that, and I did somewhat of a good job. And then on from there, I have this, which sets conditions. I only have one condition, which is ratios, which are set here. And it's a bit of a mess, and the way I stored it is a little iffy, but it works. And this is a little messy, and it gets sent. And this complex mess is just a bunch of tables that output what I just showed you. But yeah, that it displays the ratios now, which is really cool. And then from the conditions, it sends the triggers out. So I only sent 2 of them out. And then it goes to the sampler, and this sampler is taking whatever samples you put into it. And right now, here's the sample map. And what it is I figured, like, what's the easiest way I could put all the samples into a kit without making like a terrible number of importing tons of files all the time. And I thought, well, what if I condensed all those samples to one long sample? And that's what I did. That's what this is right here. And so it's 32 samples. Every 4th sample is the bass sound. So a bass sound would be like a kick, a snare, a hi-hat. And then the 4 sounds in between would be like different forms of the kick or snare, hi-hat. So it'd be like maybe a kick, maybe a distorted kick, maybe a different type of kick, maybe a different type of hi-hat. So yeah, different forms of that. So that's what this is, just a really long sample. I didn't even know I could zoom in like that. So bam, it just shows. And it chops them up. And it decides when to play them, and yeah. And you can change the pitch with some simple decibel pitch to frequency factor, and then yeah, it divides it by 32 as I said before, and it adds 4 to get each bass sound. And you can change each sound with the macro and the fader, and yeah. It's only sending out the lefts. And then this wavetable, I don't know. I made it a while ago. I just kind of plugged it in, but I don't feel like it's the best use of it. So I explained a lot about how I made it, but I didn't really show you what it does. So what it does is really all not that complicated. So bam, I can make a pattern. Actually, I kind of have to go on my globals right now. It's a lot of work just to do something that seems pretty simple. I guess that's good. So when I press play, it'll play this pattern that I made. And it's set for just this, just to play once. When I set the length, it'll play through this, and it'll play through this. So let's make something in here. Pretty simple. So it'll play through the first one, and then it'll play through the second one. So it'll play through this, and it'll play through that. You can hear that. I hope so. I have no way of like showing that right now. But that's what it does, and this kind of like sets the length, and then I could set the pad mode, the ratio. So if I set the ratio for the hat, it's gonna play every time this pattern's triggered. That's how I set it up. Then I could, every time that pattern triggered 1 out of the 2 times it's triggered, it'll play. So it's kind of confusing, but that's how I did it. So you can hear that. There's the second time it was triggered, and then it goes to the next pad. First, there you go. So that determines when it does and does not play, which is pretty cool. I could add more stuff, I don't know. Then I can change the pitch. This is for the, no, this is the change the sample, so you can see me doing that real quick. So I change it to a restored kick and I put it back. I can change the snare. And then this, I believe, changes the pitch of each sample when I click that. So yeah, that's pretty cool. And I can change the volume, turn the kick all the way down. So basically these 8 pads kind of represent these same 8 pads this way, if that makes sense. I guess I could have done something to represent that better, but yeah. And then what I can do, which is, I like this a lot. This is kind of cool. So all these notes are quarter notes, but what if you want triplets? So this button right here, I could click, so this whole group is in quarter notes. So I can click that, set it to quarter notes. And it has some bugs because it showed that up. Then if I want to set triplets, I click this and then I set it to triplets. So quarter notes, triplets. So you can hear that. Watch, I'll do that real quick. Oh, let me turn the ratio off so it's, and let me clear that annoying pattern. So the ratio back to 1. Oh, it's still there. He's still there. Okay. Okay, so I have a pattern going. I forgot what I was doing already. Oh yeah, quarter notes and triplets. Watch, I'll change it. So let's actually fill in these notes so it sounds a little clearer. So this is quarter notes. Then I'll set the triplets. And what happens, what it does is basically, since triplets wouldn't really go through this whole thing, it only plays through 6 of the pads instead of all 8. So if I took out the 2 pads, it actually would sound the same. Watch. Because it cuts out this last 2. And then if you see where my mouse is, this actually changes the speed. I could have came up with a different method of doing that. But altogether, that's what that does. Yeah, it's pretty cool. I mean, it's when you make something, you think it's going to be like this great thing, and it's going to do these awesome things. But it took a while to do this little bit, and I'm kind of happy I did it. So I'm going to show you also what I call an igorifier that I made. It takes a sample, it chops it up in yeah. And then it plays those chops randomly. Those chops are based off time divisions. And it's all synced to the BPM, so it'll stretch the sample based on, what the BPM is. And then it'll decide whether it wants to make the sample a higher pitch or a lower pitch, or if it wants to reverse it, and it's all random. So it randomly chops it up according to BPM. It equals chops, so chops 16th or 8th notes, it's random. Whether it chops the 8th or 16th notes or whatever, it's random. And then whether it's played reversed, played forward, that's random. Whether it's sped up, slowed down, it's random. So it's basically a randomizer. That's the best way I can explain it. So let's take a sample. Take some of the samples I have that aren't really my samples. So let's just, easy way to show it is basically, I guess, a drum. Let's take a drum loop. What do I want to do? Let's do this. So that's the loop. If I throw it in there and then I hit randomize, it'll play that. So let's listen to that. So you can hear it took it and randomized it. And I can change the speed factor, which basically multiplies the speed by multiples of 2. So it's still in tempo. And this position change, I think it changes like how often the chops are going through. Like, so 0 is really fast. So we hear one version of it. Let's actually take some instruments. It's always more interesting with instruments. Let's take this. So let's drag that into there, hit random, and play it. So that made a pretty cool loop, and I can make it faster with this. Or I could randomize it again. I get some pretty cool results from this. Like, it's super simple. It's just a lot of randomized values that like you wouldn't want to set all yourself. Because I started making this and I was like, I don't want to set all this myself. Random. Okay. So I'm also, I call it big. I don't know why I call it these things. I'm also working on this other thingy. I guess I don't need to show a controller for this. If it shows up. So this is kind of the same thing. I tried to organize it a little bit better. So you see, I'm trying to multiplex the signals. I'm just using this. This is just to test it, basically. So when I drop a sample in, it gives me all its useful information. So when I drop this in, excuse me, it'll tell me how long it is, how long it would be if it was quantized to the current BPM, the size of the sample in seconds, how many beats there are in the sample rate, how long the division is when it's divided by this number right here, the max volume of the sample, and the number of peaks, which is set by this threshold. And it changes as I set the threshold lower and lower, because the lower the threshold, the more peaks there would be. So I can go through my samples and I can show you how this actually quantizes the sample. So this BPM is at 100, and if this is at 100, then it should quantize it to the same number of seconds that are here. And it does. The seconds are the same because the BPM is the same. When I change the BPM, the quantized seconds are longer because the BPM is slower. And if I make it a faster BPM, it's actually a little slower. It actually should be faster. But yeah, it is a little buggy. But this is basically trying to get information out of the other table framework macros that you wouldn't otherwise be able to get. And then I had for this to work, I had to do something a little different, because if I connect it directly to here, I get CPU issues. Watch the CPU. Right now it's not doing it really. Well, it's a bad example because now it doesn't do it. But anyways, it does do it sometimes. So I synced it to the display clock. You're only gonna see it. I only synced it. When this knob moves, it's gonna trigger the display clock only when it moves. So it'll send through event clocks according to as fast as the display clock only when the knob moves, which I kind of stole from some other ensembles. And this, I have to set the threshold for this max actually sets the max threshold for the number of peaks. And I do that before I actually went in and wrote the peaks, because you have to first have an iteration that gets sent to the peaks, which is this set threshold, and then have an iteration that gets sent to write the peaks, because if you don't have a threshold before you write the peaks, then it doesn't work. It kind of makes sense. But yeah, that's everything I've been working on so far. It's just kind of cool to show it off.